The United States, Israel, Iran. Missiles are flying. Air defenses are activating. Drones are crossing borders. Explosions light up the night sky. Headlines focus on fire. But fire is not the foundation of this war. The foundation is something smaller than your fingernail. A semiconductor. Every missile that changes direction mid-air. Every drone that identifies a target. Every interceptor that calculates trajectory in milliseconds. Every encrypted military transmission. Every satellite feed guiding decisions in real time. All of it depends on advanced silicon. Not metal. Not fuel. Not courage. Silicon. And here is the part most people miss. Weapons today are not mechanical systems. They are computational systems wrapped in metal. They think before they move. They calculate before they strike. They adapt while in flight. Without advanced chips, they lose precision. They lose intelligence. They lose edge. And when a military loses its edge, it does not notice immediately. It notices gradually. Updates slow down. Guidance becomes less precise. Electronic warfare becomes less effective. Enemy countermeasures improve faster. One side evolves. The other stagnates. Modern warfare is no longer about who has more hardware. It is about who upgrades faster. Iteration speed is power. And iteration speed depends on compute. Now here is the structural problem. Advanced semiconductors are not produced everywhere. They are not interchangeable. They are not easily replaced. They are manufactured in extremely concentrated facilities. Facilities that cost tens of billions of dollars to build. Facilities that take years to construct. Facilities that only a handful of companies on Earth can operate at scale. If access to those chips is restricted, a military does not collapse overnight. It falls behind quietly. It continues operating, but with ceilings, with limits, with systems that cannot evolve at the same speed. And in modern conflict, speed of evolution determines dominance. A missile without upgrades becomes predictable. A drone without improved compute becomes detectable. A radar system without updated processing becomes vulnerable. Artificial intelligence does not exist in isolation. It requires hardware capable of sustaining it. Real-time targeting, sensor fusion, autonomous coordination. These are not software problems alone. They are silicon problems. Remove access to advanced silicon, and you remove the ability to scale intelligence on the battlefield. Now consider how fragile this dependency is. Global semiconductor supply chains are optimized for efficiency, not redundancy. One disruption, one export restriction, one political decision, one choke point, and upgrade cycles stall. Weapons remain operational, but they stop improving. Meanwhile, someone else's continue to evolve. That asymmetry compounds. Slowly, relentlessly, and compounding disadvantage is more dangerous than sudden defeat, because it is invisible at first. Wars used to be decided by stockpiles. How many tanks? How many shells? How many aircraft? Now wars are increasingly decided by compute density, by processing capability embedded inside every system, by how quickly software can adapt to enemy behavior, by how fast intelligence models can retrain on new data. You do not need to destroy an enemy's air defense network. You just need to slow its computational evolution. You do not need to eliminate drones. You just need to prevent them from getting smarter. And you do not need to fire a single missile to weaken a country's military capability. You just need to control what its systems depend on. This is the shift few people are discussing openly. The real battlefield is not just geographic. It is industrial. It is logistical. It is technological. Control of semiconductor supply is leverage. Leverage scales without explosions. If a nation loses access to advanced chips, it does not lose weapons. It loses the ability to modernize them. And modernization is survival. Artificial intelligence in warfare is not theoretical. Autonomous drone swarms, AI-assisted missile defense, predictive targeting algorithms, cyber intrusion systems guided by machine learning. All of them depend on high-performance compute. High-performance compute depends on advanced semiconductors. Advanced semiconductors depend on concentrated manufacturing ecosystems. That concentration creates power. Not explosive power. Structural power. The kind of power that determines ceilings. The kind of power that defines who can escalate and who cannot. Now zoom out. Who controls the export licenses? Who decides which countries gain access to advanced chips? Who determines which systems can legally be shipped, and which cannot? Those decisions are not battlefield decisions. They are regulatory decisions. But their impact shows up on the battlefield. Military strength is no longer just about defense budgets. It is about supply chain access. It is about fabrication capacity. It is about whether a country can secure the silicon it needs to sustain its upgrade cycles. Without sustained upgrades, even advanced weapons become static, and static systems are defeated by adaptive ones. The next war will not simply be fought with missiles. It will be fought with update cycles, with processing capacity, with AI training loops that refine targeting models in real time. And if one side's loops run faster, that side gains an exponential advantage, because compute scales, and advantage in compute compounds. The uncomfortable reality is this: modern war does not scale without semiconductors, and semiconductors do not scale without infrastructure control. Infrastructure control does not require explosions. It requires policy, capital, and concentration. This is not a conspiracy. It is structure. Technology defines capability. Access defines limits. And limits determine outcomes. In previous centuries, control of oil shaped global power. In earlier eras, control of steel and industrial capacity determined dominance. Now control of advanced silicon shapes military ceilings. Countries that secure access can evolve. Countries that cannot stagnate. And stagnation, in a world of accelerating technology, is decline. The headlines show missiles, but the underlying leverage is silicon. The explosions are visible. The structural dependency is not. Modern conflict is no longer just kinetic. It is computational. And computation is not evenly distributed. It is concentrated. It is controlled. And in a world where intelligence is embedded inside weapons, control of the hardware that enables that intelligence is not just economic power. It is strategic power. The next escalation may not begin with a launch. It may begin with a restriction, a denial, a delayed shipment, a blocked export. No smoke, no sirens, but consequences that unfold over years. Because when a country cannot upgrade, it cannot keep pace. And in modern warfare, falling behind quietly is more dangerous than losing loudly. Modern war does not collapse in a single moment. It erodes through dependency, through ceilings, through invisible constraints. And the nations that understand this do not just invest in weapons. They invest in control. Control of fabrication, control of supply chains, control of who gets access to the silicon that makes modern military intelligence possible. The battlefield may look physical, but the leverage is industrial. The conflict may look explosive, but the control is structural. Missiles make headlines. Semiconductors make outcomes. And the countries that control them do not just influence markets. They influence the balance of power. They influence escalation. They influence history. Modern war does not scale without semiconductors. And semiconductors are not neutral. They are controlled. And control is the real weapon.